Black ink is not actually black. It looks like one colour, but chemistry can split it into several. Hello everyone, I'm Molly, and today I'm going to be taking you through the Biro Column Chromatography activity. In this, we will complete an experiment to show you how chromatography can be used to separate mixtures. This activity is based on the webpage in the ChemBAM website, linked below. Here is the background. Teachers, feel free to use this as a part of your lesson. When we synthesize a compound in chemistry, we're often left with a mixture in our flask. This can include the desired product, the unreacted starting material, side products, and byproducts. Whether you're in a research lab or an industry, you need your product to be pure. One method of separating your desired compound from the undesired impurities is column chromatography. This is the standard setup for column chromatography. The steps are as follows. Load the column with a stationary phase. This is often done by pouring in a mixture of stationary phase and mobile phase. Add your sample mixture and let it soak into the stationary phase. Add a mobile phase and let it move down through the column. As the sample moves down the column, different molecules move at different speeds. If you have a good combination of solvent and stationary phase, you can get different components of your mixture to separate out into bands that you can collect separately. The stationary phase is what the molecules in your mixture stick to. It's a solid material with a lot of chemical functional groups on its surface. Depending on the material, these can be hydrophobic or hydrophilic. Molecules will travel down the column quicker if they're more attracted to the solvent. Molecules that interact strongly with the stationary phase will stick to it and therefore move a lot slower. Silica is a common stationary phase. You can find silica in sand on the beach, but silica columns are a little bit different. It has a lot of holes in it, called pores. The surface of all of these holes are covered in hydroxide groups bound to the silicon. We call these silanol groups. The holes give the silica a really high surface area. This means it has a lot of space for molecules to stick to. So the aim of this experiment is to investigate the best silica stationary phase to separate the colours in black ink. This is what you will need.
This is the Black Corolla Super Tip water soluble pen. This is the best brand we found, and this is just a vial of the pure ink squeezed out of this pen. This is the white silica desiccant beads. Make sure that you don't buy the ones with a colour indicator. Here we have a beaker of water and many plastic pasture pipettes inside. We also have a Biro pen. This is the Nice Day SBM 1.0 medium, because it's easier to pull apart and dimensions work for our optimization as it affects the size of the column. We also have a bag of cotton wool here, and over here we have the scales, which are specific to 0.01 grams. Next to it we also have some collection vials that will collect anything of small volume between 1 and 5 milliliters. In this vial we have 70% isopropanol, which is also known as rubbing alcohol. We've made this using 7 milliliters of 100% isopropanol and 3 milliliters of water, but you can also buy 70% rubbing alcohol online. Make sure you also have any sort of white vertical objects, anything you can kind of tape your Biro pen to, and you need to have it upright. Make sure you also use clear tape that you can attach your Biro pen to.
This is how to complete this activity. If you are completing this as a part of a lesson, feel free to show this either before or after the students have a go themselves, depending on what works better with your group.
Here we have some white silica beads that we have heated at 100 degrees over the weekend. However, we are in a research lab, so at home you can heat the white silica beads in an oven at 120 degrees and stir every 30 minutes. So this is how I'm going to crack the white silica beads in water. So here we have a beaker of water. So we crack the silica beads so that we increase the surface area of the silica beads and so that it can fit inside of the Biro. I'm just going to pour it into the water now. So as you can see, they are cracking in the water now. So here are some cracked silica beads that we have made earlier in a beaker of water again. So put this to one side, and now we are going to prepare the diluted ink in water. Okay, so to extract the ink from the pen, just open it up and just cut about here. Just above this line with either pliers or wire cutters. You can just take it out then and you'll get like a spongy ink cartridge. Once you extract it, you should get pure concentrated ink like we have here. It should look like this. Okay, so here we have 3 vials. This is the pure concentrated ink from the Crayola pen. Here is one that we made earlier with 5 milliliters of water and 1 drop of the concentrated ink. This makes it 1 to 100, but to get 1 to 200, you collect 2.5 milliliters of the 1 in 100 and you add it to another vial with 2.5 milliliters of water and you mix together. So this is the 1 in 200 of ink to water. Okay, so now I'm going to take apart the Biro pen to have our column. Okay, taking the ink out and take the bottom part out. So now you have this, and this will make up your column. You won't need any of these parts, you can chuck these away, but make sure that you have this part of the pen, because when you're packing the cotton into the bottom of the column, you can use this to stuff it down into the column. So now I'm just going to measure out 0.11 grams of cotton using the scales. Okay, so as you can see, we have roughly 0.11 grams of the cotton in here. So I'm going to take that out. I like to fluff up the cotton before I start packing it into the column as well. Okay, so now we're going to start packing it into the Biro pen using this part of the pen. Okay, just like so. And now it's at the bottom like this. You can start packing it by just squishing it into the bottom. Okay, now I'm going to measure the length of the cotton inside of the column. So this is roughly 2.5 millimeters. And this is before putting the water inside. Okay, now we're going to measure the drop rate of the water and count how many drops runs through the cotton. So I'm putting some water into the pen using a pipette, and this is really important, so make sure that the water runs through the cotton fully so that it's completely wet. So I wouldn't measure the first about 3 drops, just to make sure that it's completely wet. Now using a timer, I'm going to count how long it takes for it to drop into the vial. Okay, so that was about 7 seconds. You can do it again just to make sure it's consistent. Okay, again, 7 seconds, so we know that that's going to stay like that for now. Okay, so I've now filled this up with water. Make sure that it's about 3/4 of the way up the pen, because the further down it is, the slower it's going to take to drop. So to get the drop rate consistent, make sure it's always in roughly the same place. So yeah, anywhere between like 5 and 7 seconds that we found, that should work for your experiment. So I'm now measuring it after adding the water, and you can see again it's about roughly 2.5 millimeters, which is about the same, so that's fine. Okay, so now I've set up the column. I've taped it onto a white object with clear tape so that you can see colours that are running down the column. I've also got a vial here, so collect any drips running through. Okay, so now I'm going to start adding some water into the column using a pipette. So fill it all the way to the top, just like this. And this is going to keep running through, so make sure that it's always filled to the top. You want to make sure that this is all the way to the top, because you can't get the silica beads dry. You have to keep them wet at all times. If you do get the silica beads going dry because you forgot to keep filling this to the top, this will produce air bubbles and create gaps in the column, which you don't want. So now I'm going to add the silica beads, which are hydrated in water. Again, make sure it's straight to the top before you start adding anything. I like to just use a spatula and scoop it down the beaker and just drop it straight into the water. Other scientists like to do this in different ways, but this is just the way that I'm doing it. At this point, once it's filled to the top, make sure it's again with water, but you can give it a flick, and the silica beads will fall down and slightly condense. Okay, I'm now going to measure the gap between the silicone beads and the top of the column, while also making sure it's still filled. So the space between the silica beads and at the top of the column was 1 centimetre. Here I am now adding the 3 drops of ink into the column. Make sure that you add the 3 drops just as the water goes past the silica beads. Straight after, make sure that you get a pipette of water and fill it back up to the top. As you can see, the colours are already starting to separate. The blue and the red separate down the column clearly. As the red starts to drip out, switch your vial at the bottom so you start collecting the red drops from the bottom. Again, make sure that you're always filling to the top of the column. Keep your eye on it at all times. As you can see, now all the red has run out of the column, so I've switched the vial again to collect some of the water coming out. Here I am starting to add the isopropanol to the top of the column. This should allow the blue to run through the column easier than the water would. This vial that is filling up should be containing water. Just as the isopropanol starts to drip through, make sure you switch the vial then. As you can see at this point, all the water is at the bottom of the column, so I've now switched the vial so that it collects only this, the blue and the isopropanol. As you can see, the blue that is now collected in the vial is much brighter than before. These are the 4 illusions that we have collected from our column. The first one is just water alone. The second one is the red that we have collected with water. The next one is the blue that we've collected with the water. And the last one is the blue that we've collected with the isopropanol. Because isopropanol is less hydrophilic than water, the blue ink's interactions with the silica was weakened and the ink ran through the column easier. Therefore, this is why we collected more blue ink at the bottom, as shown in this file. For more information about how the technique is used in today's research, check out the link below.
I hope you enjoyed this fun activity, and I hope it has helped you try and understand chromatography a little bit more in depth. Please check out our other experiments, videos, and pupil resources on our website, linked below. And if you have any questions, feedback, or would like to request a visit, please fill out the form in the Contact Us section to get in touch. There are also some other videos that ChemBAM has made, so if you are interested, please check out our YouTube channel as well. Thank you so much. Bye!